Good morning, everyone. Myself, Rohit Kulkarni. Once again, I welcome you for today's session. As all of you know, we are going to see lesson number 5, Heat of Science-1. So it's my request to each and every student that they can open the textbook, page number 64. And before starting today's point, just I will tell you in short, within 1 minute, that yesterday what are the points we have seen. Yesterday we have seen the difference between heat and temperature. Then we have seen about latent heat. What is the meaning of latent heat? Then we have seen the melting point, boiling point. Apart from that, we have seen latent heat of fusion, latent heat of vaporization. We have seen all these concepts, and the most important thing, we have seen the regulation. What is the meaning of regulation? What is its definition, and what are the activities? Because that point is a very important point from the exam point of view. So these are the points we have seen yesterday. Now today, if you see on page number 64, we are going to see the point anomalous behavior of water. So open your textbook, page number 64. We will begin our today's session. Now see, anomalous behavior of water. In general, when a liquid is heated up to a certain temperature, it expands, and when cooled, it contracts. Remember this. What is given when a liquid is heated up to a certain temperature? So we have seen some of the activities, that what happens when ice is turned into a liquid, and up to certain after that the temperature does not rise. So when liquid is heated up to a certain temperature, it expands, and when it cooled, it contracts. Water, however, shows special and exceptional behavior. If we heat water from 0 degrees Celsius to up to 4 degrees Celsius, it contracts instead of expanding. Remember this, if we heat water from 0 degrees Celsius up to 4 degrees Celsius, it contracts instead of expanding. At 4 degrees Celsius, its volume is minimum. Remember this point because this can be asked for the filling the blanks objective type question. Because at 4 degrees Celsius, its volume is minimum due to contraction. So when the temperature reaches 4 degrees Celsius, the volume of the water is minimum. Why it is minimum? Because of the contraction. Now suppose if the water is heated further, suppose we are heating it continuously further. Now what happens? It expands and its volume increases. So if you are heating it continuously, its volume expands and its volume increases. So the behavior of water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Underline the definition. The behavior of water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Understand this point, because from this point only we are going to see the next point, which is very important, that is Hope's apparatus. A very important point it is. So what is the definition for anomalous behavior of water? The behavior of water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Right? I just will say one example. If 1 kilogram of water is heated from 0 degrees Celsius and its volume is plotted as function of temperature. So we are going to plot one graph. So that will be volume versus temperature. You can see the graph in the slide. We get the graph shown in the figure. At 4 degrees Celsius, the volume of water is minimum. It means that the density of water is maximum at 4 degrees Celsius. Now just look in the graph, you can see the red color is shown. So the volume of water at 4 degrees Celsius, the volume of water is minimum. Yeah. So what we can say that the density of water is maximum at 4 degrees Celsius. So just this is an example given to understand what is the anomalous behavior of water. But to understand in detail, we'll see the next point. So remember the definition. The behavior of water between its temperature from 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Now see, the next point is study of anomalous behavior of water using Hope's apparatus. The anomalous behavior of water can be studied with Hope's apparatus. In Hope's apparatus, a flat bowl is attached to a cylindrical container as shown in the figure 5.5. So if you have textbook in front of you, what you can do, you can see the figure 5.5, the Hope's apparatus shown. So in Hope's apparatus, what is there? A flat, so we can say this is construction. A flat bowl is attached to a cylindrical container. There is a provision to attach thermometers above to measure temperature T2 and below to measure temperature T1, the flat bowl on the cylindrical container. If you see the figure, hmm, we can attach two thermometers. The above, the thermometer T2 to measure the temperature, and below thermometer T1 to measure the temperature on the cylindrical container. Water is filled in the cylindrical container and the mixture ice and salt, that is freezing mixture, is put in the flat bowl. Now if you see the cylindrical container, in that means there is a water, and whatever the flat bowl is there, in that there is a mixture of ice and salt. Yeah, so this is the construction of Hope's apparatus. Once again, just I will repeat. Now in Hope's apparatus, a flat bowl is attached to a cylindrical container. So you can see one cylindrical container, and around that a flat bowl is attached. Now there is a provision to attach thermometers. Means we can attach two thermometers. Above it is thermometer T2 and below it is thermometer T1 to measure the temperature. Now water is filled in the cylindrical container. So whatever the cylindrical container is there, in that we are going to fill some water, and whatever the flat bowl is there, in that we are going to put a mixture of ice and salt. So in the figure it is shown. Clear? So this is the construction of a Hope's apparatus. So this is all we are going to do. Now see what happens. So during the study of anomalous behavior of water using Hope's apparatus, temperature T1 and T2 are recorded after every 30 seconds. So when we are doing this activity, what we have to do, we have to measure the temperature T1 and T2 after each and every 30 seconds, and we are going to note it. So this is our observation. So what after doing the observation, then only we are going to understand how that it works. Now the temperature are plotted on the y-axis. Just look in the graph. The temperature are plotted on the y-axis and the time in minutes on the x-axis. Right. So you can see in the graph it is shown there. So this is the temperature time graph. So the temperature is plotted on the y-axis and the time is plotted on the x-axis. Clear? So this is shown in the graph. Now see what actually this graph shows. Please understand. The graph shows that initially both the temperature T1 and T2 are identical. Right? Just look in the graph. If you look at the graph, what you will understand that initially the temperature T1 and T2 both are identical. Means initially they both are same. However, as the time passes, now what happens? We have to measure the after. We are going to take observation after every 30 seconds. Clear? So as the time passes, temperature T1 of water in the lower part of the cylinder decreases fast. Now already we have seen in the construction that there are two thermometers, above the thermometer T2 and below thermometer T1. Clear? So initially what we have seen that temperature T1 and T2 both are same, both are identical. But as the time passes, temperature T1 of water in the lower part of the cylinder decreases fast, while temperature T2 of water in the upper part of the cylinder decreases comparatively slowly. So by looking at the graph, what we understand that the temperature T1 of water in the lower part of the cylinder, it decreases very fast, while the temperature T2 of water in the upper part of the cylinder decreases comparatively slowly as compared to that of the T1. But however, Once the temperature T1 of the lower part reaches 4 degrees Celsius, that is 4 degrees Celsius, it remains almost stable. Hmm? Now, what happens once the temperature T1 means below, hmm, at the lower part, when it reaches up to 4 degrees Celsius, it remains almost stable at that temperature. So, when the temperature reaches up to 4 degrees Celsius, it will remain stable. It will not go further, it will not become less. It will be 4 degrees Celsius. At that temperature, T2 decreases slowly to 4 degrees Celsius. Therefore, thereafter, since T2 starts changing rapidly, it records 0 degrees Celsius first. Now, after this, what happens? The thermometer, which is above, hmm, which is at the upper part. So, that since T2 starts changing rapidly, it records 0 degrees Celsius first, and after that, the lower thermometer T1 records 0 degrees Celsius temperature. So, here what happens? The thermometer T2 initially first it reaches to the 0 degree Celsius, and then the thermometer T1 will record the temperature 0 degree Celsius. So the point of intersection of the two curves shows that the temperature of the maximum density. So if you look in the graph, the point of intersection, just look in the graph which is given. So whatever the point of intersection is there of the two curves, it shows the temperature of maximum density. So that near about that is 4 degrees Celsius. If you can see, it is shown with the dotted line. Both T1 and T2 they are meeting at some point, and if you see that line which is given in the dotted, and if you see the temperature, it is somewhat 4 degrees Celsius. So it reaches the maximum density. Now see, this is Hope's apparatus is explained with the help of the graph. Now we'll see actually how the Hope's apparatus works. Here now, whatever the explanation we have seen with the help of the graph that actually what happens. But now we'll see how the Hope's apparatus it starts working. So see, what is the question? How can we explain this observation? Clear? Now to understand this, you should have Hope's apparatus in front of you. So just look at the Hope's apparatus whenever I'm explaining. Initially, the temperature of water in the middle of cylinder lowers due to freezing mixture in the outer ball. Now see what happens initially. The temperature of water in the middle of the cylinder, it lowers. Slowly, what happens? The temperature of the water in the middle of the cylinder, it lowers. And why it happens? Because of the freezing mixture. Freezing mixture means mixture of ice and salt, which is there in the flat bowl. Hmm? Since the temperature of water there decreases, right? The temperature of the water decreases, its volume decreases, and its density increases. Please underline this. See what is given. Since the temperature of water there decreases, its volume also decreases and its density increases. Just opposite. The water with higher density moves downwards. So water with the high density, what will happen? It will move towards the downwards. Therefore, the lower thermometer T1 shows a rapid fall in the temperature, and this continues till the temperature of water becomes equals to 4 degrees Celsius. So what happens because of this? The lower thermometer T1 shows rapid fall, means it will it will decrease very fast, and this continues till the temperature of water becomes equal to 4 degrees Celsius. So till what temperature it will fall? Till the temperature of the water in the lower part of the cylinder reaches up to 4 degrees Celsius. Now, once when the temperature of water starts decreasing below 4 degrees Celsius, its volume increases and density decreases. Clear? Remember this: when the temperature of water starts decreasing below 4 degrees Celsius, its volume increases and its density decreases. Clear? Initially, upside in the upper paragraph, what you have seen, since the temperature of water decreases, its volume decreases and its density increases. Now, here what is given: when the temperature of water starts decreasing below 4 degrees Celsius, its volume increases and its density decreases. It therefore moves in the upward direction. So now what happens? It moves in the upward direction. Initially, what we have seen, because of the high density, the water moves towards downwards. Now, what will happen? It will now, because here the water will move in the upward direction. So the temperature of water in the upper part T2, therefore decreases rapidly to 0 degrees Celsius. Now here what happens? Now the thermometer T2, the temperature T2 of the water will decrease very fast, very rapidly to 0 degrees Celsius, and the temperature of water in the lower part, that is thermometer T1, will remain at 4 degrees Celsius for some time and then decreases slowly to 0 degrees Celsius. Now here what will happen, that temperature T2, hmm, in the upper part will decrease very fast to 0 degrees Celsius. But the temperature T1, which is there in the lower part, it will remain constant. It will remain constant at 4 degrees Celsius for some time, and then it will, what will happen? It will decrease slowly to 0 degree Celsius. Clear? So this is what, in this way, we can explain the Hope's apparatus. Please understand this point is very important from the exam point of view. It can be, you can explain with the help of graph, or you can explain straight away, means the construction and the observation. Clear? How can we explain this observation? So whole paragraph you have to write in the points. Clear? So hope so all of you understood what is the this point. Now we'll move on the next point. Hmm? Now depending on this only, some questions we are going to see, which is given on page number 66. Now see what is that? How will you explain following statements with the help of anomalous behavior of water? Please go through this, both the questions. Both the questions are very important. Now see what is the first question. These questions can be asked for the due reason. In regions with cold climate, the aquatic plants and animals can survive even when atmospheric temperature goes below 0 degrees Celsius. So the figure is given, figure 5.7. Clear? So what is our question? In regions with cold climate, the aquatic plants and animals can survive even when the atmospheric temperature goes below 0 degrees Celsius. So how do they survive? That we are going to see in the answer. Now see what is the answer for this. Right? So figure 5.7, you have to draw that figure for this answer which is given. So in cold regions, during winter, the temperature of the atmosphere falls well below 0 degrees Celsius. So in cold region, during winter, the temperature of the atmosphere, it falls below 0 degrees Celsius, means it goes in the minus. Clear? Below 0 means it will go into minus. As the temperature decreases, the water at the surface of the lakes and ponds starts contracting. Clear? As the temperature decreases, the water at the surface of lakes and ponds starts contracting. Hence, its density increases and it sinks to the bottom. So, as the water starts contracting, what happens is density increases and it starts sinking to the bottom. This process continues till the temperature of all the water in the lake falls to 4 degrees Celsius. So, till this process goes on continuous. Till what? Till the temperature of all the water in the lake falls to 4 degrees Celsius. As the water at the surface cools further, that is, its temperature falls below 4 degrees Celsius, it starts expanding instead of contracting. Right? Initially, what we have seen, the water starts contracting. But as the water at the surface cools further, means its temperature falls below 4 degrees Celsius, it starts expanding instead of contracting. Therefore, its density decreases and it remains at the surface. Initially, the density was increasing. Now, here what happens, because of the temperature, water temperature falls, its density decreases and it remains at the surface. The temperature of the water at the surface continues to fall to 0 degrees Celsius. Finally, the water at the surface is converted into ice, but the water below the layer of the ice is at 4 degrees Celsius. Clear? What happens? Finally, the water at the surface is converted into ice. The surface water will be converted into the ice, but the water below the layer of the ice, means the water which is underground below the layer of the ice, it will remain same at 4 degrees Celsius. Ice is a bad conductor of heat. Hence, The layer of the ice at the surface does not allow transfer of heat from the water to the atmosphere. As the water below the layer of the ice remains at 4 degrees Celsius, fish and other aquatic animals and plants can survive in it. Clear? So this is the answer for the first question. In region with cold climates, the aquatic plants and animals can survive even when the atmospheric temperature goes below 0 degree Celsius. So please go through this question. This question, both the questions are very important. They can be asked for the give reason. Such type of questions can be asked for the give reason. So understood what is the answer for this. Now one more question is given. See what is the second question. In cold regions in winter, the pipes for water supply break and even rocks crack. Hmm? So see what is the answer for this. Sometimes water enters into crevices of the rock. Crevices means small pores or holes we can say. So sometimes water enters into the crevices of the rock, and when the temperature of the atmosphere falls below 4 degrees Celsius, water expands. So when the temperature falls below 4 degrees Celsius, water expands. Even when water freezes to form ice, there is increase in its volume. As there is no room for expansion, it exerts a tremendous pressure on the rock, which cracks and breaks up into small pieces. So as there is no room for expansion, it exerts a tremendous pressure on the rock and which cracks and breaks up into small pieces. So this is about rocks. Now we'll see about pipes. Now in winter, the pipes for water supply even they also crack. So what happens? So in cold countries in winter, the temperature of the atmosphere falls below 0 degrees Celsius. When the temperature of water falls below 4 degrees Celsius, it expands. Same it is. Hence, the water in pipe expands even if ice is formed. There is an increase in the volume. As there is no room for expansion, water or ice exerts a large pressure on the pipes, and hence the pipelines carrying water burst. Clear? So this is the answer for the question number second, that in cold regions in winter, the pipes for water supply breaks and even rock cracks. So two questions are there. One is for the pipes, how the pipes breaks, and what is rocks crack. So this is for the rock, and the second answer is for the how the pipes breaks. Clear? So both the questions are very important. Now see what is the next point. So here we have completed our first point, that is dew point, Hope's apparatus and anomalous behavior of water. Now we'll come to the next point, that is dew point and humidity. About 71% surface of the earth is covered with water. Clear? So all of you know that near about 70% of the earth is covered with the water, and remaining 20% is covered with different components. Now due to constant evaporation of water, water vapor is always present in the atmosphere. The amount of water vapor in the atmosphere helps us to understand the state of the daily weather. So whatever the weather is there, whether it is hot, whether it is cold, humid, dry. So how it understands? We understand because the amount of water vapor present in the atmosphere. The presence of water vapor in the air makes it moist, and this moisture in the atmosphere is called humidity. So whatever the presence of water vapor is there in the air, it makes the air moist, and this moisture in the atmosphere is called as humidity. Hmm? So just one example, for a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain. So for a given volume of air at a specific temperature, there is a limit on how much water vapor the air can contain. If the amount exceeds this limit, the excess vapor converts into water droplets. If suppose the amount, if whatever the limit is given, if it exceeds, then the excess water vapor converts into the water droplets. When the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. Remember this, when the air contains maximum possible water vapor, underline this if you have the textbooks with you. When the air contains maximum possible water vapor, it is said to be saturated air. Because once further we are going to see the definition of unsaturated also. So this is the definition of saturated air. When the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. The amount of vapor needed to saturate the air depends on the temperature of the air. If the air temperature is low, it will need less vapor to saturate the air. Clear? So the amount of water vapor which is present, it depends on the temperature of the air. If the temperature of air is very low, then it will need less water vapor to saturate the air. Now we'll see one example. Now see, for example, if temperature of air is 40 degrees Celsius, it can contain 49 gram of water vapor per kilogram of dry air without condensation. Hmm? Two examples are given. This is the first example. Suppose if the temperature of air is 40 degrees Celsius, it can contain 49 gram of water vapor per kilogram of dry air without condensation. And if the amount of water vapor exceeds this limit, then the additional vapor also will condense. Suppose if the temperature of air is 20 degrees Celsius, which is half of the above, it can contain only 14.7 gram of water vapor per kilogram of dry air without condensation. And if the vapor content in air is less than the maximum limit, then the air is said to be unsaturated. So this is the definition for unsaturated air. Just once again, I will repeat both the definitions. When the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. And if the vapor contained in air is less than that of the maximum limit, then the air is said to be unsaturated. So from this paragraph, we should know both the definitions of saturated air and unsaturated air. So saturated means when the air contains maximum possible water vapor, it is said to be saturated with vapor at that temperature. And unsaturated means what? If the vapor contained in air is less than that of the maximum limit, then the air is said to be unsaturated. Okay? Now from these two definitions, we are going to see the definition for dew point temperature. Now see what is the definition. Suppose unsaturated air at a certain temperature is taken and its temperature is decreased. A temperature is reached at which the air becomes saturated with water vapor, and this temperature is called the dew point temperature. So you can underline the definition of dew point temperature. Suppose unsaturated air at a certain temperature is taken and its temperature is decreased. Unsaturated air is taken, its temperature is decreased. A temperature is reached at which the air becomes saturated with water vapor, and this temperature is called the dew point temperature. The vapor content in the air is measured using a physical quantity called absolute humidity. So whatever the vapor content in the air, which is vapor present in the air, it is measured by using a physical quantity. It is called as absolute humidity. The mass of vapor present in a unit volume of air is called absolute humidity. So you can underline the definition for the absolute humidity. The mass of vapor present in a unit volume of air is called absolute humidity. Generally, absolute humidity is measured in kilogram per meter cube. So this is the unit for absolute humidity. The absolute humidity is measured in kilogram per meter cube. Clear? So many definitions are there already. As I told you, go through each and every definition. So here we have got the definition of dew point temperature and absolute humidity and even its unit. Now further, again today one more definition we are going to see. Now see, the feeling of humid or dry nature of air not only depends on the amount of vapor in the air, but it also depends on how close that amount is for making the air saturated with vapor. See what is given here. The feeling of humid or dry. Whenever we feel whether it is humid or dry of nature of air, it is not depends on the amount of water vapor in the air, but it also depends on how close that amount is for making the air saturated with the water vapor. It means that it depends on the temperature of the air also. Means feeling of humidness or dryness in the air. In short, it depends on what? It depends on the temperature of the air. Then the ratio of actual mass of water vapor or vapor contained in the air for a given volume and temperature to that required to make the air saturated with vapor at that temperature is called a relative humidity. Yes, so this is the definition for relative humidity. What is the definition? The ratio of. Ratio means all of you know the ratio of actual mass of water vapor contained in the air for a given volume and the temperature to that of temperature to that required to make the air saturated with vapor at that temperature is called the relative humidity. Now below that you can see even the formula is also given. Now here we have written the formula for percentage relative humidity. If you are writing formula for percentage relative humidity, you have to multiply by 100. If you are writing only the formula for relative humidity, no need of multiplying with the 100. So what is the formula for the relative humidity? Just I am telling the formula for relative humidity. Relative humidity is equals to actual mass of water vapor contained in the air in a given volume divided by mass of vapor needed to make the air saturated in that volume. So this is the formula for relative humidity. Suppose if you are writing the formula for percentage relative humidity, then you will write the formula as it is and just you will multiply by 100. So you will get in the will get answer in percentage. Clear? So learn the definition and even its formula. Now after doing considering this whole concept, what we are going to see how the air is dry and how the air is humid. So this is very important. See what I'm telling. The relative humidity at dew point is 100%. Please remember this, by heart this. Hmm? The relative humidity at a dew point is 100%. First point. Second point. If the relative humidity is more than 60%, we feel that air is humid. Clear? If the relative humidity is more than 60%, we feel that air is humid. If the relative humidity is less than 60%, we feel that the air is dry. Please understand this point and buy at it because this is it can ask for the objective type of questions. That when the air is humid and when the air is dry. So you should know this that if the relative humidity is more than 60%, we feel that air is humid. And if the relative humidity is less than 60%, we feel that the air is dry. And the relative humidity at the dew point is 100%. Is it clear? Okay. Now, just one more point is there. That is the last point of our. Now, say again, some questions are asked. So first, we'll go through this paragraph and then we'll see what are the questions. Now, say during winter season, you may have observed a white trail at the back of a flying plane in a clear sky. Hmm? Now, during the winter season, if you have seen the aeroplane or flying plane, you can see a white trail. White trail means some white-like substance you can see behind the aeroplane. Actually, what is that? As the aeroplane or as the plane flies, the vapor released by the aeroplane engine condenses and form clouds. Clear? So whenever the plane is flies in the sky, whatever the vapor is there which is released from the engine, it condenses and they forms clouds. If the surrounding air is having more relative humidity, remember if the surrounding air means wherever the plane is flying, if that surrounding air is having more relative humidity, it takes a long time for the white trail formed by condensation of vapor to disappear. Clear? If the surrounding air having more relative humidity, then whatever the white trail is formed, it will take long time to disappear. But if the relative humidity of the surrounding air is less, either, so what will happen? Either the size of the white trail may be small or it may not even get formed. So totally it depends upon the relative humidity that when we see the white trail behind the aeroplane, behind the plane. So it totally depends on what? It totally depends upon the relative humidity. If the relative humidity of the surrounding air is less, either the size of the white trail may be small or it may even not get formed. And if the relative humidity of the surrounding air is more, then it will take a long time for the white trail to disappear, means it will remain as it is. Clear? So why it happens, you should understand. Some you also have seen this. Whenever the aeroplanes are flying, sometimes you can see a white line like structure behind the aeroplane. So this is the reason for this. Clear? So whenever we are learning something, you should uh, take some examples from our daily life. Then only this concept will be cleared for you. Clear? So this exam we have seen so many times that white trail which is seen behind the aeroplane, but we don't know the reason. So you maybe today you understood what is the reason for that. Clear? So remember, if the relative humidity of the surrounding air is less, either the size of the white trail may be small or it may not even get formed. If the relative humidity of the surrounding air is more, it takes a long time for the white trail formed by condensation of water vapor to disappear. Clear? Now, depending on this, two questions are asked. So we'll go through that question, see what is this, try this. Take a bottle of cold water out of a refrigerator and keep it outside for a while. Observe the outer surface of the bottle. This is the first question. Clear? You know what will happen. Suppose if we are taking a water bottle out of a refrigerator and we are keeping it outside for a while. So what will happen outer surface? You can see small droplet, water droplets are formed on the outer surface of the bottle. Then drops of the water. So the answer is given below that. Drops of the water can be observed on the outer surface of the bottle. Clear? So what we will see, we'll see the some drops of water on the outer surface of the bottle. In the same way, if you observe the leaves of plants or grass or window glass of a vehicle in the early morning, we see water droplets on the surface. Clear? All of you have seen in the winter season what we see, or even now, if you early morning, if you see plants or grass, leaves of plants or grass, even if you see the windows, window glass of the vehicles, what we can see, we can see the small droplets which are collected on the surface. Clear? Now, see, through these two observations, we sense the presence of water vapor in the atmosphere. So these two examples are given for what purpose? To understand there is a presence of water vapor in the atmosphere. When air cools, due to decrease in temperature, it becomes saturated with water vapor. Remember, when the air cools due to decrease in temperature, it becomes saturated with water vapor, and as a result, the excess water vapor gets converted into tiny droplets. So whatever the excess water vapor is there, it gets converted into tiny droplets, and the dew point temperature is decided by the amount of water vapor in the air. So dew point temperature, how it is decided? It is decided by the amount of water vapor present in the air. Clear? So this is about dew point and humidity. Already we have seen the definition for dew point temperature. It will give so this is about the dew point and humidity. Yeah. So today we have seen the anomalous behavior of water, the definition of anomalous behavior of water. Then we have seen the Hooke's apparatus, which is very important from the exam point of view. Go through that. This question can be asked for the 3 to 5 marks. Then whatever the use your brain power. Two examples we have seen, as I told you, that can be asked for the duration. So that also go through this. And the last point we have seen about dew point and humidity. Definition of dew point temperature. What is saturated air? What is unsaturated air? Then definition for relative humidity, its formula, and when the air is humid and when the air is dry. And at last we have seen the two examples, that why we see the water droplets outside the water bottle when it is kept out of a refrigerator. Clear? Now we just will so here we have completed our today's session. Whatever two point we are going to we have discussed. Now we'll move on, just we'll evaluate ourselves. Now see, depending on these points, you are going to answer this question. Now see, what is the first question? Define dew point temperature. If any students know the definition, I just want the definition of dew point temperature. So you can answer that. Define dew point temperature. You can raise your hands and you can unmute yourself and you can answer it. Define dew point temperature. Those students who knows the answer for the first question, they can raise your hand. You can unmute yourself and you can answer it. Define dew point temperature. You have to define it. You have to give you have to give definition for that. Hello, ma'am. Otherwise, you can answer the second question also. If the relative humidity is more than 60%, we feel that air is. Already I told you the answer for both the questions, because it is, I told you the questions are very important.
Hello, sir.
Hello.
Sir, if the relative humidity is more than 60 degrees, we feel that air
60%.
is
60%, not degree, 60%.
60%. We
We
feel
feel
that
that
air is
air is
humid.
okay, very good, right? So answer for that is humid. If the relative humidity is more than 60%, we feel that air is humid. Just answer the third one also. If the relative
Sir, if the
humidity is less
relative
than
humidity is less than 60%, we feel that air is dry.
dry, right? Very good. The answer for it is dry. If the relative humidity is less than 60%, we feel that air is dry. And just last question, you have to tell the formula for relative humidity. Already I told you
Sir,
you have to.
the actual mass
Formula.
of water vapor contained in the air upon mass of vapor needed to make the air saturated into 100.
That is formula for percentage. If it is asked only relative humidity, you can write down only actual mass of water vapor contained in the air in a given volume divided by mass of vapor needed to make the air saturated in that volume. And if the formula is for percentage relativity, then write down as it is and just multiply by 100. Clear? So what you can do, you can once again you can revise all the things, whatever we have seen today and whatever we have seen yesterday. Clear? And whatever the remaining point is there, unit of heat, specific heat capacity, and heat exchange, that will continue tomorrow, day after tomorrow in the next period. Clear? Okay. Thank you, students. And if any students have any doubt, you go through that and you can ask me day after tomorrow.
Okay, thank you, sir. Students, still if you have any doubts, please raise your hands. Sir has taught us a very important topic, which is really important for the exam point of view. Most of the time, these questions are being asked regarding an anomalous behavior of water, relative humidity. All these questions are asked every now and then. In most of the years, we have seen that. So please, if you have not understood or if you're having any question mark in your mind, please raise your hand. So I think, okay, once child is raising the hand. Samad, Samad Darji, you're raising your hand. Okay, so no one is raising the hand. We can wind up here.
Okay, ma'am. Thank you, ma'am. Thank you,
Okay,
students.
thank you so much. Yeah, thank you so much.